All right, one more example. Wanted to do one where we were rotating around the y-axis rather than the x-axis. And before we dive into this, maybe just let me remind you of the formula that the book had. Is really based on 2 pi radius, right? So maybe better than saying f of x here is really just saying r, the radius. And when we were rotating around the x-axis, the radius was the function value, but when we're rotating around the y-axis, things will look a little bit different. So let's take a look at what the graph of this thing looks like. So it looks about like this. We are rotating this thing about the y-axis, so that's our axis of rotation there. And we're going from y is 1 to y is 2, so from there to there. So we're taking that shape and rotating it around. It's actually a little bit too big for the fit the rest of my screen, so I'm going to scrunch it a little bit, but see if we can copy it over there. And then the rotation. It's a terrible circle. Okay, there's the rotation for the bottom, and on the top. Yep. Comes out something like this. I've been looking at your homework. A lot of you are better artists than I am, so hopefully you get the basic idea. Though we've got kind of a shape like that. The sides are a little bit steeper. But one of the things I wanted to point out here is that the radius, when we do 2 pi radius, the radius of one of these goes from here until it hits the curve. The radius, if this point on the curve is xy, the radius is just x, which will actually make our formula a little bit nicer. Okay, so let's get rid of this graph and see if we can just set up the formula. And this time, rather than having 2 pi y or f of x, radius is just going to be 2 pi. Let's get on the right layer. It's just going to be 2 pi x for us. Okay, so we'll go back to the example and say we are setting up this thing. So we are rotating 2 pi radius, and then the square root of 1 plus derivative of the function squared dx. We are going to have to work out the derivative of the function squared. We're also going to have to talk about the limits of integration. Let's talk about that a little bit. What goes here and what goes here, because keep in mind, we are in X world. We cannot put some Y limits on this thing. So we need X limits instead of Y limits. Fortunately for us, there's a nice little relationship between X values and Y values sitting right here. I don't know why I just lost my pen. But anyway, the formula is there. So we can say if Y is 1, funky. Oh, I see. It's drawing under. Anyway, if y is 1, then you can just say, hey, then that means 1 equals cubed root of x, and you can cube both sides and say if y is 1, then x is 1, and if y is 2, then 2 has to equal the cubed root of x, and cube both sides, and x equals 8. So not too hard to change our y limits into x limits. So our x limits go from 1 to 8. And yeah, we do need to get the derivative in here as well. So if y is x to the 1/3, then y prime is 1/3 x to the negative 2/3. All right, now we get to actually work the integral. Right, the setup is done. Now let's see what kind of fun we're actually going to have doing this integral. So I'm going to move the 2 pi out front, limits from 1 to 8. I've got an x there. And inside the square root, I've got 1 plus, and then when I square this stuff, the fraction becomes 1/9. Power raised to the power means multiply the powers, so this becomes x to the negative 4/3. Or if I move it to the bottom, it will become x to the 4/3 on the bottom. So let me rewrite this a little bit. 1 plus 1 over 9x to the 4/3. I'm going to keep working on the stuff inside the square root for the moment. So let's get a common denominator. Be 9x to the 4/3 over 9x to the 4/3 plus 1 over 9x to the 4/3. Now we've got the common denominator. We can add the two together. So inside the root, we have 9x to the 4/3 plus 1 all over 9x to the 4/3. The mechanics here are getting pretty similar to the last problem we did. I'm going to split this apart into 9x to the 4/3 plus 1 square root over square root of 9x to the 4/3. This one on the top with the plus, there's not much I can do about that. But the one on the bottom where it's just a single term, I can take the square root of 9. I can take the square root of x to the 4/3. So I'm going to leave this stuff on the top and say 9x to the 4/3 plus 1 all over 3x to the 2/3. Yeah, 4/3 goes down to 2/3. So keep in mind the square root is a 1/2 power. 1/2 times 4/3 is 2/3. Okay, I think we're actually finally ready to try to tackle this integral again. Let's put the whole integral back together. Make myself a little space right here. So the integral is 2 pi 1 to 8 x square root of 9x to the 4/3 plus 1. And this is all over, oops, got a dx on the end, all over 3x to the 2/3. I'm going to go ahead and move the 3 all the way out front. And I'm going to put the x to the 2/3 next to this other x that's outside the square root because I'm about to cancel those. So a full x divided by an x to the 2/3 is an x to the 1/3. And I know we're getting deep into the algebra of working this integral. Really, in some ways, setting up this integral is the new thing for surface area, and we got it set up just fine. Doing it is going to work us back through some of our U substitution language. So x to the 1/3 square root of 9x to the 4/3 plus 1 dx. Okay, we're not done yet. I need a little more room, so let's move on to a new page. Okay, so this is where we were. We're still just working on doing this integral. And there's stuff inside the square root, and there's stuff outside the square root. And it could be nasty, but fortunately, the stuff outside the square root kind of looks like a derivative of the stuff inside the square root. Makes me think about our old friend u substitution. So let's just give it a shot and see if it works. So we'll say, suppose u is this stuff inside the square root. That means du would be, let's see, the 4/3 comes down. 9 times 4/3 would be 12. X to the 1/3 dx. And taking a look at what I've got over here, I can see this stuff, of course, is just going to turn into u. This and this together are the same as this right here. So I'm going to take this equation, divide both sides by 12. So I'll get 1/12 du equals x to the 1/3 dx. And I think I'm ready to make my substitutions. So 2 pi over 3 is a constant. Going to leave the limits of integration off until I get back into the x world. But for my brief foray into the u world, have the square root of u and 1/3, or x to the 1/3 dx is the same thing as du and 1/12. Okay, so we're actually in pretty good shape for doing the integral now. I'm going to factor the 1/12 out also. So this becomes 2 pi over 36. Integral of u to the 1/2 du. Finally, I think we're going to make it. Simplify my fraction. Pi over 18. This integrates to 2/3 u to the 3/2. And it's not about u, so let's rewrite this as pi. Let's see, that's 9 times 3 is 27, pi over 27. So that was just combining these two right here. So pi over 27, u to the 3/2. And u is actually 9x to the 4/3 plus 1. All that to the 3/2. All that evaluated at 8 and at 1. I know this is getting to be a long example, but we're getting there. So let's finish it off. So plugging in 8. Let's see, cubed root of 8 is 2. 2 to the 4th is 16. 9 times 16, I can't do it in my head. Plus 1, all that to the 3/2. That was just plugging in 8. And then plugging in 1. Give us 9, 10 to the 3/2. Let's see, so 9 times 16, let's see, 144, I think. I should grab a calculator, but so there's the final answer. If they want an exact answer, they might actually want a decimal answer. So you'd have to grab your calculator and crunch that. So you can see why they don't give you a whole lot of surface area problems where you have to work them all the way out. This was just x to the 1/3. It wasn't a complicated function, but the integration and the final answer end up being fairly complicated. So your homework, a few of the problems are going to say just set up the integral. And there's going to be a couple others that say actually go ahead and do the integral, and the integral will be doable for those. Not necessarily easy, but doable. All right, go ahead and tackle surface area for tonight. We've got one more application in Chapter 8, and then we'll be on to exciting new stuff in Chapter 9.